So we have finished the algorithm, right? It's complicated, but anyway, we finished Shor's algorithm. I think you all have all the fundamental knowledge to understand more complicated one. Just try to trace the qubit. It will be very useful. And now I will talk about Bloch sphere. Usually people discuss Bloch sphere at the beginning of the class, but I swap it, I put it at the end because I realized that you don't need to know quantum mechanics, you don't need to know Bloch sphere. It's just purely linear algebra to understand the algorithm. And also Bloch sphere sometimes have some confusion to you if we try to study too early, in my opinion, because I feel that people will think that why 0 plus 1 is not equal to 0, because one is pointing up, one is pointing down. They will think that it's like that, but it is not, right? But let's just discuss what it means in this class. So qubit, as I said, is how many dimensions for one single qubit? 2 dimensions, very good. But it is not the dimension that we have in our table, on our table, right? Why is that? Because it has alpha and beta can be complex number. So it's in a space that we cannot feel, right? We live in a real space, right? So if that is the case, how can we represent it visually? And we use something called Bloch sphere. And why we can do that? So let's go through the math to understand why we can do that. So we say the psi, a general state, is alpha 0 plus beta 1. Again, alpha and 0 are complex number. So I can assume alpha equals to its magnitude times e to the power I, let's say delta alpha. Is that okay? A complex number equals to its magnitude and the phase, right? So e to the power I delta alpha. Of course, delta alpha is an angle, is a real number. So similarly, beta equals to beta's magnitude times e to the power I delta beta. So with this, can you tell me how many degrees of freedom do we have? Degrees of freedom means how many parameters you need to fix in order to fix a vector. Like on the 2D plane, what is the degrees of freedom? 2. Yeah? Because you need to fix the x and y, then you fix a point, right? So here, how many degrees of freedom do we have in order to fix a vector, a general 2D complex vector? 4. Let me spell this out. Degrees of freedom. Someone say 4. Why? Very good, right? Because a complex number has 2 degrees of freedom, right? It's just that you have 2 different complex planes, right? So you need to fix. So we say it is 4 degrees of freedom because we need alpha, we need beta magnitude, we need delta alpha, we also need delta beta, right? We have 4 degrees of freedom, okay? But is it really 4 actually? Remember that in quantum computing or in quantum mechanics, the magnitude of the vector needs to be what? Need to be what? Huh? Can you say louder? Yes, thank you. Because it need to be normalized, right? Psi square must be equals to 1, which means alpha square plus beta square must be equal to 1. So there is an extra constraint. If I know alpha, I should know beta. If I know the magnitude of alpha, I should know the magnitude of beta. If I know the magnitude of beta, I should know the magnitude of alpha. Right? So I lost 1 degree of freedom. So because of this, the degrees of freedom of this system is only 3, not 4. Okay, you cannot say I want to have alpha equal to 1000 and beta equal to 100. That is not what you are allowed to do, right? You can have alpha equal to 1 over square root 2, and then beta will be 1 over square root 2. I mean, its magnitude. It can be plus minus 1 over square root 2 plus minus 1 over square root 2i, but then that will be the phase will capture it, right? But the magnitude is fixed. So we have 3 good degrees of freedom. So if that is the case, I want to do one more step. I will just let alpha magnitude equals to cosine theta divided by 2. Beta magnitude equals to sine theta divided by 2. Okay? So I have 3 degrees of freedom with this 3 parameter now. I have theta, I have delta alpha, I have delta beta. Is that okay? So now I don't care about alpha magnitude and beta magnitude. I care something called theta. Is this a valid substitution? Check it. Alpha square plus beta square equals to cosine square theta divided by 2 plus sine square theta divided by 2 equals to what? 1, right? Sine square any angle plus cosine square any angle is 1. This is identity. So I just need to pick a theta. Once I know theta, then I know what is alpha and beta, right? I can use the theta to fix these 2 degrees of freedom. So I only have 1 degree of freedom plus the delta alpha and delta beta. Is that okay? Now we have 3 degrees of freedom. Okay, good. So because of this, then I can write it in this way. Then psi, a general psi, will be equals to magnitude of alpha, so that is cosine theta divided by 2, e to the power I delta alpha, 0, plus sine theta divided by 2 e to the power I delta beta 1. Okay, do you see this? General vector is alpha 0 plus beta 1. I transform alpha and beta to alpha is cosine theta divided by 2 e to the power I delta alpha. And then beta is sine theta divided by 2 e to the power I delta beta. They are the coefficient for 0 and 1. I did not do anything special. Except now, I have the magnitude represented by theta because they need to have their square need to be summed to 1. And then I have the phase spelling out in this e to the power I term. Right? So for those who are very good in complex number, probably you can jump to this directly. I'm just going through step by step so you understand the background, right? So I want to do one more thing to make it even nicer. So what I'm going to do is to take out a phase, e to the power I delta alpha plus delta beta divided by 2. I take out a common factor. Maybe you will see that after I finish. So I take out that common factor, then the inside this e to the power I delta alpha need to subtract the whole thing. So it becomes I delta alpha minus delta beta divided by 2, 0, plus sine theta divided by 2, e to the power I, but negative delta alpha minus delta beta divided by 2, 1. Now, looks very complicated, but you can just check if I'm correct. First of all, I keep cosine theta over 2, sine theta over 2. I have 0, 0 here, but I have this extra term, right? Just multiply this term to here. Delta alpha plus delta beta. When you multiply to it, it's exponential, so you just add them together, right? So e to the power alpha plus delta alpha plus delta beta plus delta alpha minus delta beta. So this becomes 2 delta alpha divided by 2. So it is just I delta alpha. This one, multiply this term, becomes this. Do you see this? This terms, multiply this term, becomes this term. Similarly, this term, multiply this term, I have delta alpha, negative delta alpha, so they got cancelled. Delta beta, this is positive delta beta because I have 2 negative, right? So this one becomes e to the power I delta beta. So they are the same. What I'm trying to do is just to take out a common face of these two terms. Then I let, what do I do? I call it gamma. Gamma equals to delta alpha plus delta beta divided by 2. I also let phi equals to delta alpha minus delta beta. Then what happened to this one? What is the common phase now? How do I write it if I do this substitution? What is the first term? How do we call this term now? I let delta alpha plus delta beta divided by 2. That's gamma. So this is e to the power I gamma, right? I just substitute it. And then I have cosine theta divided by 2. How do I call this term? E to the power delta alpha minus delta beta divided by 2. Actually, sorry, I do the wrong substitution. I want to call this So my cheat sheet is a little bit messy, but actually I want to call this beta. Sorry for that. Alpha. I want to do delta beta minus delta alpha, right? So what is this now? Negative I phi divided by 2. Very good. Okay. And then how about the second term? Sine theta divided by 2 e to the power I phi divided by 2, right? Because I am doing phi equal to delta beta minus delta alpha. And the whole thing is 1, right? Any questions? Although there are some math, right? But the point is, do you see what I'm trying to do? We have two complex numbers. We have two complex numbers. And what I'm trying to do is group them by grouping them, by applying the normalization condition and grouping them to take out a common phase. So that originally I have 4 degrees of freedom. Now I have 3 of them. But I group them so that the 3 degrees of freedom appear as gamma as a global phase, theta to each of them, and then phi to each of them. Right? So I should also say now the degree of freedoms is still 3. They are gamma, theta, and phi. Right? Instead of the beginning, we have this 4 degrees of freedom, or in the middle, with this 3 degrees of freedom. Now we have this 3 degrees of freedom for gamma, theta, and phi. Make sense? Okay? So we have 3 degrees of freedom. Think about this. Okay. Now, how How about this global phase? I call it global phase. Why we want to single this out? Gamma is the global phase. What does it mean? It means it is the common phase for both 0 and 1. Okay? This is not important. Okay? It has no physical meaning. Why? For example, if I ask you the expectation value, which we learned earlier already, right? What is the expectation value of psi on an operator m, right? For example, this n can be like sigma z or whatever. What is the expectation value? How do you find it? Do you remember? You sandwich psi right? This is the expectation value. Do you remember? Forgot. Doesn't matter, right? Just remember that. I want to measure the expectation value of sigma z of a vector. I put sigma z at the middle, right? And then I put the bracket sandwiching it. Then that will give me the expectation value. We did it in the assignment, remember? I asked you to find the expectation value by using this method and also just by the reasoning of probability. You get the same result. That is the expectation value, right? I just want to tell you that if I try to add an additional phase to it, maybe I should not do this. Right. This is the expectation value. Consider this expectation. Now, if psi becomes e to the power, let's say I gamma, an extra phase, I just give an extra phase, then the expectation value becomes maybe it'll be easier to show you by writing also the bra. What does the bra look like? If I have an extra phase to the cat, this one becomes what? The conjugate. Very good. So you still have the cat, but then any complex number becomes e to the power negative I gamma. Okay? And then the new expectation value is psi e to the power negative I gamma m e to the power I gamma psi, correct? But e to the power I gamma, e to the power negative I gamma are numbers. I can move them. I can bring them to any place. And they cancel each other. Becomes 1, right? So this is equals to psi m psi. Right? So you see that because in physics, all we can get is through measurement for any quantum system. You can say however great it is, just like people who tell you, I'm a very nice guy, I treat friends very well. After all, whether I'm telling you the truth or I'm lying, you just need to measure, right? You treat me well, let's go out for fun, and how I treat you or whatever. However complicated, you have lots of theory, right? From Bible, from Quran, from what? That, oh, I'm a great guy. But eventually, you are measuring what I'm doing. that has a physical meaning, right? So if you add a global phase to a wave function, it has no effect to the final measurement, right? So that's why global phase is not important. Similarly, think about the inner product of two. The inner product is what importance in many physical situations, right? If you just have the global phase add to two qubits at the same time, they got cancelled, right? Okay, so that is what I want to say. But of course, it is important if now it's not a global phase. It's you have a system, then that is not the global phase of the whole system. It's only the global phase of this qubit. Now then you have something to do with other qubit. If you don't, actually I cannot say that. Yeah, it's still global phase to everyone, because global phase to a qubit is a global phase to the whole system, because we do it through tensor product. Okay, so but what I'm trying to say is the relative phase between each component is important, but the global phase is not important. Make sense? Okay, so that's why, because of this, so for 1 qubit, of course we can ignore the global phase. Okay, so as a result, we can say psi equals to cosine theta divided by 2e to the power negative I phi divided by 2 0 plus sine theta divided by 2e to the power I phi divided by 2 1. Compared to what I have here, I remove e to the power I gamma. I only keep this. So now I can represent a general qubit state with only two parameters. Now I have 2 degrees of freedom, which are theta and phi. Done. Okay, it was 4 degrees of freedom. Due to normalization requirement becomes 3. And then due to the dumminess of the global phase, it becomes 2. So I can describe any qubit by using theta and phi through this equation. Okay. Now, if I can describe with 2 real parameters, then it means I can put it in a 2D plane, right, if I want. So I really can put on my table. But the problem is, for theta and phi, it doesn't take all values. Right? So putting on a plane is not a good thing. Turn out that I can put it on the surface of a unit sphere. Because, now this is the equation I showed you earlier. If I consider the point on this unit sphere and I use the spherical coordinate, I have theta, which is the polar angle. I also have the phi, which is azimuthal angle. But now, because it's a unit sphere, I don't need to consider R. And this sphere fits very well to this equation. And this is called the Bloch sphere. So that's why I want to say, and that this sphere is not the real space the qubit reside, right? Because at least you saw that we remove the phase. It is not completely equal to the space the qubit reside. And second, it is not in our real 3D space. But we embed the 2D space in our real 3D space. That is what we have done. We embed it in this space, but it does not reside in this space. Make sense? Now, then you will see that 0 and 1, while one is pointing up, one is pointing down, they are not the vector in our 3D space. So do not expect adding 0 and 1 will give me nothing. It's not 0 does not equal to -1. The reason 0 is pointing up is because I will show you later, we have theta equals to pi. Theta equal to 0. Cosine 0 give me 1. And then cosine 0, sine 0 over 2 give me 0. And that's why it's pointing up. Okay, and of course there has other usage we will discuss in the next class. It turned out that this also matched well to our many experimental setup. For example, if we apply magnetic field in the z direction, its eigenvalue turned out to be 0 and 1. If we apply magnetic field in the x direction for a spin qubit, then it turns out to be plus and minus. So it has this relationship to the 3D space. It does have some relationship, but again, it's not a vector living in our 3D space. I want you to keep reminding yourself about it. Okay. Phi? Yeah, phi is this azimuthal angle measured from this x-axis on this. Sorry for my English, I just spell it. Let me just spell it. Yeah, how do you pronounce it? Yeah, azimuthal angle, okay. This is phi, right? So that is how much you run around the equator, okay? And that's how we label our globe, right? The Earth, right? We have latitude and longitude. Basically, that is the, and of course, they measure in different direction. But again, this is spherical coordinates, which you can go back to check. Okay. Any questions? Now, I spent a lot of time on this, but now I hope you have the rationale, right? Why we have this Bloch sphere and why I cannot treat it as the vector in the real 3D space. Okay, we're just embedding in our real 3D space. Just like on the table, you put the map of the Earth. The point on the Earth does not reside on your table, right? You kind of embed what you understand about this Earth on this 2D sheet, right? Okay. Then let's study some of the points. For example, what if theta equals to 0 and then phi equals to 0? It's pretty easy, just plug in. Again, psi equals to cosine theta divided by 2 e to the power negative I of phi over 2, 0, right? This is the coefficient for the 0 basis. Sine theta divided by 2 e to the power I phi divided by 2, 1. Then just plug in. Becomes cosine 0 divided by 2 e to the power negative I 0 divided by 2, 0 plus sine 0 divided by 2 e to the power I 0 divided by 2, 1. Okay? So what is cosine 0 again? 1, right? And then e to the power 0 is also 1, right? So this one gives me 0. I can maybe write it down plus 0 times 1. 1 times 0 plus 0 times 1, right? Which is equals to 0. Now let's look at this. At the pole, North Pole, now I can call it North Pole, right? Theta is what? 0. polar angle is 0, right? You did not move because it's measuring from here to here. If you go to equator, it becomes 90 degrees. And then this azimuthal angle is measuring from here. Now, I say it's 0, then it means that you don't go down and you don't rotate. So it's still North Pole, right? So it gives me 0, which is correct, right? The North Pole has the theta equal to 0 and phi equal to 0. Okay, makes sense, right? Now, another question is, what if, this is 1, let's use another color. What if theta equals to 0 and phi equals to anything? Let me call it, how about call it Z? Okay, so let's plug in to see what's going on. Psi, again, this is cosine. Theta is 0, 0 divided by 2, e to the power negative I, c divided by 2. I wrote another one. And then 0 plus sine 0 divided by 2 e to the power I c divided by 2, 1, right? What is the first term? The first term, cosine 0, is 1. But this is no longer 1 because it is a number not equal to 0. I just need to keep it. Okay. How about the second term? 0. This whole thing is 0. Right? Because sine 0 is 0. Where is this point? Again, you look at this. Because your theta is 0, so I'm still at the North Pole, right? You look at this vector, right? This point, still at the North Pole. But you say that actually I rotate about the z-axis by z. At the North Pole, you keep rotating. You are still at the North Pole, right? So is that contradicting to what we understand? No. Because the only difference between these two states, they are two different states. They are completely different. But the difference is just that it has an extra global phase. Again, we don't care. And that is because we already, when we map to the Bloch sphere, we already say, I'm going to ignore gamma, right? And that's why this information is lost. So now I hope you understand at every point on this Bloch sphere, it can have infinite, it corresponds to infinite a number of states in the space that we are really working on. But their difference is only by one global phase. Okay? Okay, so good. So I will do one more slide and then maybe take a look at the midterm. Now, then we will look at another extrema, which is, well, actually, I want to say a little bit more, so as an example. So just quickly, okay? Maybe here I don't have space. I didn't know that. So what if theta equals to pi, but then phi equal to 0? You just plug in. But from here, you already know, right? Can you tell me if theta equals to pi, what state is this? 1. You go all the way to South Pole, right? Pi, right? You rotate by pi. So we just plug in and check. Psi equals to cosine pi divided by 2, because it's divided by 2. E to the power negative I 0 divided by 2, 0, plus sine let me put it plus sine pi divided by 2 e to the power negative I 0 divided by 2, 1. Then, of course, cosine pi divided by 2 is 0, so the whole term is gone. Sine pi divided by 2 is 1. E to the power 0 is 1. So this one gives me 1. This is as expected. The south pole is state 1. It corresponds to state 1. Okay? So let's take a look on 2 other cases. What if theta equals to pi divided by 2 and then phi equal to 0? Based on what on the drawing on the left, right? Which state it is? Theta equal to pi divided by 2 and phi equal to 0. Just think about which point has an angle pi divided by 2 to this positive axis pointing up. Plus. Good. Yeah, because plus is 90 degrees to this vertical line. And then you don't rotate because we define the phi by how much you are away from plus. Right? So we expect this is going to be plus. Okay? Let's check if that is the case. Again, I will write the equation. Psi equals to cosine theta divided by 2 e to the power negative I phi divided by 2 0 plus sine theta divided by 2 times e to the power I phi divided by 2 1, right? So let's plug in. This becomes cosine. Theta is pi divided by 2, so this is pi divided by 4, right? And then I have cosine. Okay, this is easy. 0 divided by 2, so this is 1. Not cosine, sorry. What is that? E to the power, right? E to the power negative I 0 divided by 2 0 plus sine pi divided by 4 e to the power I 0 divided by 2 1. What is cosine pi over 4? 1 over square root 2, right? 0 plus 1 over square root 2, 1, because sine pi divided by 4 is also 1 over square root 2. This is equal to what? 1 over square root 2, 0 plus 1, which is plus by definition. By the definition we have been using. So here again, right, if someone who only learned, like middle school student, only learned the vector addition, and you show it this, and if that student doesn't know what is bracket, thought that is just a, know that this is a vector, that student might say, 0 plus 1, 2 vector, isn't that it becomes nothing? But turn out it becomes plus, right? This is an important implication. Again, why this is just you are embedding a 2D space to our 3D space. And those points are just correspond to the space we cannot touch. It's not really in our space. Okay? Let's do one more exercise, right? What if theta equals to pi divided by 2 and phi equal to pi divided by 2? Which state do you expect, which point on the Bloch sphere do you expect it will be? It is. So think about, first of all, your theta is pi divided by 2 from the vertical axis, so it is must be on the equatorial plane, 90 degrees, right? And then it is 90 degrees from the plus is where? You mean this one? Yeah. So we expect it to be this one, okay? Which is an eigenvector of sigma y. 0 plus I1 divided by square root 2. Okay, let's try. Then we have psi equals to cosine, pi divided by 4, e to the power negative I pi divided by 4, right? Because the phi is also pi over 2. So phi over 2 is pi divided by 4. Zero plus sine pi divided by 4 e to the power I pi divided by 4, 1. Is this okay up to here? How I do the substitution? Right? I just substitute theta with pi divided by 4, 2 and phi with pi divided by 2, right? Then we just go through the math. We already know cosine pi divided by 4 is 1 over square root 2. But what is e to the power I pi divided by 4? Right? We can although I know you know that, but let's just quickly go through this. I pi divided by 4 equals to cosine pi divided by 4 plus I sine pi divided by 4, right? Actually, sorry, I actually, you can do that, but actually my cheat sheet has a better method. Maybe I just do that, sorry. Okay. So what I'm going to do is to take out a global phase, right? I continue to write this for now. E to the power negative I pi divided by 4, 0, plus 1 over square root 2, e to the power negative I pi divided by 4, 1. Is that okay? No negative for this one. Okay. Then I'm going to just take out a global phase. I take this out as e to the power I pi divided by 4. And then I also take out the square root 2. Then the whole thing will becomes e to the power negative I pi divided by. I actually want to take out negative instead of positive. I take out e to the power negative I divided pi divided by 4. Okay, so the first term becomes e to the power I pi divided by 2, 0. Then the second term is just 1. Do you see this? First I take out 1 over square root 2. And then I take out negative e to the power negative I pi divided by 4. So this one, so I make a mistake, right? What mistake did I make? When I take out e to the power negative I divided by 4. The first term should be nothing, right? Because I take this out. And then the second term, so let me rewrite it, should be 0 plus e to the power I pi divided by 2, 1. Right? Because if you multiply this to here, you get e to the power negative pi divided by 4. You multiply this to here, do subtraction, you get e to the power I pi over 4. Sorry for this mistake. Any questions? Maybe I have a quick pause here. Any questions? Is e to the power I pi divided by 2. E to the power I pi divided by 2 equals to cosine pi divided by 2 plus I sine pi divided by 2. What is that? Because cosine pi divided by 2 is 0, right? So this equals to I. So basically what I get here is this. I got e to the power negative I pi divided by 4 times 1 over square root 2, 0 plus I1. Is it the same as what I expect? Is it because I make an error in the label? Why they are not exactly the same? Really, their difference is just a global phase. So again, if I just plug in this, because I already ignore the global phase, it can come up with anything that is different by one global phase. The one I label here is a simplified one where I chose a global phase equal to 1 for this setup. Right? So I'm correct. There's nothing wrong here. Okay? Nothing wrong here. Right? So you need to pay attention to this. So I will stop the class here, but then I will talk about the midterm.